Thank you. All right, welcome everyone. And thank you for joining today's presentation. My name is Elizabeth Spalding, and I am the Marine Vegetation Habitat Strategic Initiative, or Marine Vegetation Implementation Strategy Lead for the Habitat Strategic Initiative. And we are very excited today to share with you the culmination of one of our recently funded projects that was led by Dr. Gary Green with Moss Landing Marine Laboratories and Tombola Mapping Lab. And he's got a great team here today. So we just appreciate you joining us. Today's webinar is being recorded, as you just heard, and so we are going to make this recording available on our Strategic Initiative website under the Funded Projects page, and we do plan to have that uploaded in the next week or two, so you can rewatch this or you can share this with colleagues for those who were not able to join us today. And we will have time at the end of today's presentation for some question and answers. We're saving about 15 minutes at the end. So please do feel free to enter your questions in the chat as we go through the presentation. We'll actually save questions for the end, but we'll keep kind of a running log of those questions and we'll return to them as time allows at the end of this presentation. So before we get started with the actual presentation, I did want to share a little bit of information about the Habitat Strategic Initiative. And so we are a multi-agency team that's led by Washington Department of Fish and Wildlife and Washington Department of Natural Resources. And we are a part of the Puget Sound National Estuary Program. And so our mission is to enable and accelerate habitat protection and restoration. And we do that through the operationalization of our 4 implementation strategies. And so those strategies include floodplains and estuaries, land development and cover, marine vegetation, and shoreline armoring. And so we also accomplish a lot of this work through a variety of different pathways. The first and foremost, and the one that you're probably the most familiar with, is our funding program. And so we do distribute EPA geographic program funding to support critical and traditionally harder to fund restoration projects, one of which you'll be hearing about today. But we also do a lot of work convening and supporting collaborative partnerships across Puget Sound and the recovery community, and also supporting and leading strategic planning processes that really center habitat restoration priorities and needs. And so if you're interested in learning more about our program or engaging with us, we really welcome your involvement, and I would encourage you to reach out to learn more about that. And so today, we're going to highlight the key findings from one of those HSIL funded projects. And this project worked to assess Pacific sand lance subtidal habitats and biomass in relation to salmon foraging habits in the San Juans. And so this project had been selected for funding in partnership with the San Juan Local Integrating Organization. And it was really based on the recognition that there is a significant gap in our understanding currently of the interactions between Pacific sand lance and salmon populations within deep water habitats. So we know a lot more about those subtidal and nearshore habitats, but we really need to have a better, more holistic understanding of those interactions spatially. And so this project is aiming to help start to fill those gaps. And it was also identified as an important project because findings from this project could help us prioritize habitats for protection from things like oil spills or other major physical disturbances that are associated with activities more prevalent in the San Juan Island area. And so this was one of those collaboratively identified projects. And we are going to hear a little bit more about how that project went and what next steps might look like. So I'm going to hand it over to you now, Gary, to introduce yourself and the team, and I will pull up your slides as you do that.
Okay, thank you, Elizabeth. It's a great pleasure to be here. And it's what I want to do is to introduce our team. We have Matt Baker, who is a biologist and a sand lance expert, as well as John Ashkoff, who has been doing a lot of work on the GIS mapping. So the three of us will present this assessment of sand lance as a forage fish for salmons in the area. So we'll start off. I'll start off with the next slide, Elizabeth, with on the agenda for this meeting. It's a team effort. This project has been an enjoyable project, and it's been with the the help of both Matt and John that we've been able to accomplish what we have so far to date. Anyways, the presentation of the findings for this project is going to start with me with the introductions. I'm going to talk about the objectives and summary mapping results, the lessons we've learned and recommendations, and then I'll turn it over to Matt Baker, who will talk about salmon gut analysis and its significance to salmon diets and foraging behavior. And he will then turn it over to John Ashkoff, who will talk about the GIS mapping aspect, the story map, the methods results that he dealt with, and a little bit about the data recovery and availability. If we can have the next slide, please. So the goals and the objectives of this project was to map locations of subtidal sandlands habitats. These would be the potential salmon foraging areas, to map occurrences of salmon foraging on sandlands, to document locations of recreational fishing where sandlands are found, to validate previous documentation of salmon feeding on sandlands by examining gut contents of recreationally caught salmon, to inform prioritization of habitats for protection of oil and other spills and physical disturbances, construct a story map highlighting salmon foraging sites that John has done, and finally to construct a GIS map projects showing results of salmon feeding on Pacific salmon and other prey. Next slide, please. So the summary of our results are such. We've over 276 bed forms have been identified and mapped and graded for sandlands potential. 80 of these have been ranked good or better for potential sandlands occupancy. Over 200 salmon stomachs obtained during the 2021 and 2022 fishing seasons have been examined. 109 stomachs contained food that were examined, 46 king with over 20% containing sandlands. So Matt Baker will get into more detail when he discusses this. Banner banks appeared as a major source of sandland salmon foraging, banks that we had previously not identified as being potential sandlands habitats. And there appears to be some association with sandlands presence in salmon diets and sandlands habitats, suggesting targeted foraging that we want to throw out for everybody to chew on a little bit here as we proceed. Next slide, please. So this is a summary map showing the results of our mapping efforts on salmon caught containing sandlands in their stomachs. Previous and present sediment sampling efforts are shown in the yellow dots with sandlands in the sediments. The brown dots are sediment samples that we collected during this project and previously that had no sandlands in them. In addition, we evaluated the dynamic bed forms with various potential to harbor sandlands, and those are shown in color outlines as well as color polygons that will be shown to you here earlier in the discussion. Next slide, please. One of the things that we found was that recreational fishers on Orcas Island regularly catch salmon in obstruction paths just south of Orcas Island. We enlisted several of these fishers to provide stomach contents for our analysis. However, there's no dynamic bed forms that have been mapped here before the study. So finding that many of the caught salmon contain sandlands, we examined our high-resolution bathymetric data, which is shown on the slide to the left, with the yellow dots and the fish symbol in them, where salmon, king salmon, were caught that contain sandlands. And we determined that the banner banks were present and may be potential sandlands tidal habitats. And these banner banks are outlined in red on the slide to the right. Banner banks are just simply areas where you have scouring taking place. If you look at the symbol with K11 on it, that's a scour depression. And during flood and ebb tides, these areas are scoured out with sediment being pushed up to the north on a flood tide, where you see K9, and that deposited sands that are well winnowed and of the grain size that sandlands would like. And the same thing happens on the B22 from the ebb tide. So these are banner banks, and we looked at these banner banks during our study as being a potential for sand lance. Next slide, please. Another place where salmon containing sand lance in their stomachs were caught by recreational fishers were offshore of northeast San Juan Island. Again, no potential subtidal sand lance habitats had been mapped here, but examination of our high resolution bathymetric data indicated Banner Bank, this number bed 829 that you see in the slide to the right, was present near where the salmon was caught. You can see the dot to the left, just above the little island there, where a salmon with sand lance in its gut were caught. This led us to further investigate other bed forms we had not identified previously, and to see where they lie in relation to where salmon with sand lance in their stomachs were caught. Next slide, please. A surprise to us was that only one salmon was caught near the highest potential sand lance subtidal habitats in the San Juan Archipelago that had sand lance in its stomach. And you can see this in the center slide and to the right, where the salmon that had sand lance in its gut was caught, shown as the fish symbol in the yellow dot. But the areas in the center slide that shows all the yellow dots, this is an area that has been sampled consistently through the last 20 years, where sand lance have been shown to be of high density. However, one of the things that we found out that this may not be an area where fishers are catching salmon while they are foraging at this habitat, because it is too deep for the present day use of fishing gear. Therefore, shallower foraging habitats are most likely targeted by fishers in the region. This led us to rating all map potential sand lance subtidal habitats for potential occupancy. And you can see that effort on the slide to the right. Number one in yellow is the highest rated sand lance subtidal habitat in the San Juan Islands. Above that in blue is a good rated habitat for sand lance. And then the ones on 5 and 6 are rated as fair and poor habitat. So this rating is what we use throughout the archipelago to identify various habitats that we think may be occupied by sand lance. Next slide, please. Now, further south of this highest rated sand lance subtidal habitat, which you can see on the slide to the right, which is up near the top of that photograph. You can see number 1 in the yellow. That was the San Juan Channel sand wave field that we have been sampling for over 20 years. But down to the south, you see in the yellow, in the red outline blue area, that is Salmon Bank. And that contains a lot of sediment with sand lance in it that we had previously collected prior to that time. Next slide, please. Here on Salmon Bank, many sediment samples have been collected with sand lance, yellow dots shown here. The brown dots are sediment samples that were collected that did not have sand lance in the sediment. Salmon was caught nearby to the west of the bank. You can see the brown and yellow dots to the left of the bank. That is where salmon were caught. The ones in yellow are that had salmon in their guts. And they may have been foraging on the bank. We also rated the bank as good potential with a dynamic bed form near its southern end that you can see in green and labeled 2 as a high potential for sand lance. Next slide. Even further south, sediment samples with sand lance and salmon caught with sand lance in their stomachs have been found on Hind Bank. Hind Bank is, you can see it as labeled as HNBK, and you can see there again the symbols for sand lance that were in the guts of salmon that were caught in this area, as well as sand lance in sediment samples that were there. Salmon caught on Eastern Bank, which is labeled EBK, did not contain sand lance, even though we rate the dynamic bed form on the bank as having a very high potential for sand lance occupancy. These need further studies, obviously, because there is other banks such as Partridge Bank, where we also rate a dynamic bed form as high, that should be investigated to see how much sand lance occupancy exists there as well. Next slide, please. An interesting note is that many of the salmon caught both in Alaska and in the San Juan Archipelago were abraded with striations along their snout and gills that you can see on the fish. You can see the Chinooks that was caught in Susha. You can see striations just below its eyeball, and you can see that on the fish just above the one that was caught off of Susha. The one caught in Alaska had sand lance in its guts, as you can see on the little photograph just to the left of the fish. This suggests to us that salmon may be targeting the subtidal habitats of sand lance, perhaps scraping along the sediment to flush out the sand lance. Next slide, please. Okay, we can run this video. This possibility of salmon scraping or diving into sand lance occupied substrate is further substantiated by this video that we collected from the submersible Cyclops just prior to taking on this investigation. And you can see here that sand lance coming out of the sand wave field in the San Juan Channel. And the motion of the submersible evidently appears to flush out the sand lance, and maybe the motion of the salmon may do the same thing. This is something that needs further investigation, and it's a hypothesis that we've come from in observing the striations along the salmons that have been caught. Next slide, please. Okay. One area we focused on is in the northern part of the study area, in the Boundary Pass and President Channel area, where the seafloor morphology is complex, as you can see in this slide. And a multitude of marine benthic habitats exist, including those that are promising sand lance subtidal habitats, as you can see in the olive green areas with D on them. That's Fraser River deposits. You can see sort of bright green areas that are labeled EBB and FBB. That stands for ebb banner bank and flood banner banks that are formed from flood and ebb tides. And then you can see striated dynamic bed forms that are also important sand lance habitats. In addition to this area is composed of many rock outcrops, as shown in the next slide, please, that are good rockfish and lingcod habitats, and many of these species prey on sand lance. This is an area sensitive to oil spill, as major tanker routes, shown in the broad yellow hashed lines, that converge in this area, may be sensitive to oil spill, as major oil tanker routes carrying heavy crude, sinkable oil, or dilbit, may spill in this area and could adversely impact the sand lance or rockfish habitats. Next slide, please. These tanker transport routes are also found in the southern area as well, and those glacial banks, blue outlined in red, would also be susceptible to sinkable oil spills. Next slide. We exhibit these maritime corridors on our map of graded sand lance potential habitats, as shown in the colored polygons of this map. Hopefully this map can be useful in any mitigation resulting from a sinkable oil spill. Here we show in green good habitats. We've rated good habitats for the occupancy of sand lance, and these would be areas that we would want to prioritize in protecting in case of an oil spill. Next slide, please. Part of this study addressed, as I've shown here, the oil spill risks, and a publication describing the risk and possible mitigation approaches has recently been published in January of this year in the peer-reviewed journal Continental Shelf Research. And this is available to anybody that may be interested in pursuing further investigation of such events. Next slide. In addition to oil spills, we looked at other potential anthropogenic influences to sandland salmon foraging habitats, such as this dynamic bed form offshore Victoria, British Columbia. Here our map bed form number 30 that you see in the slide is rated as fair potential for sandlands occupancy. We found it located a short distance downstream of the Victoria sewer outfall, from which contaminants would be swept into the bed form during flood tides. Next slide. In addition, an unknown outfall of some kind was imaged near the mouth of West Sound of Orcas Island, which could contain contaminants harmful to potential sandland subtidal habitats. That is shown as the curved ridge just above the outfall. However, fluid flow from the pipeline and also from prop scours, various prop scours, such as you see in the lower left-hand slide, which is a ferry scour, FS, pointing to the ferry scour at Shaw Island Terminal, these may be winnowing out sediment, thus producing potentially favorable subtidal habitats for sandlands, something in need of further investigation, we have found. Next slide. Okay, for this short description of what we have mapped, I would like to turn to the lessons that we've learned, and this will be further explained by Matt's and John's presentation following mine. King salmon feed primarily on herring, sandlands, and crustaceans. Banner banks now and glacial banks appear to be significant sandlands foraging habitats for salmon. Additional recruitment of citizen scientists and recreational fishers would augment ongoing collaboration with charter operators. And there's a need to extend study period for more robust statistical analysis that I'm sure that Matt is going to want to discuss in his presentation. Next slide, please. Our tentative recommendations from this project are as follows: continue efforts to obtain salmon stomachs from recreational fishers, enlist recreational fishers as citizen scientists for the project. Based on results of this project, investigate banner and glacial banks for sandlands potential occupancy using bottom sampling methods. Extend study area from San Juan County south to determine salmon sandlands foraging habitats and also into BC, Canada. Continue comparison studies of San Juan County with Sitka, Alaska, and present results of study at local scientific meetings. And I'd like to have my last slide, or my next to last slide, on acknowledgements. Our team would like to acknowledge the support that the U.S. Environmental Protection Agency provided us for funding under the Assistant Agreement contract that you see listed here. Puget Sound Partners and National Estuary Program made this, endorsed this program. The San Juan County LIO and MRC recommended and supported this program. The Washington Department of Fish and Wildlife, Natural Resources, and Ecology assisted tremendously in the administration of this project. Friday Harbor Labs, as well as Moss Landing Marine Labs, the students thereof, and boat operations were great support to the program. Friends of San Juan and Sea Dock Society also helped in providing data. Many fisher friends and charter boat operators came through and supplying gut contents for us. And one of the specific things I like to point out is Sitka, Alaska indigenous fishers jumped onto this and were very helpful, and still are very helpful in providing gut contents for the study so that we can extend it into Alaska. North Fishery Seattle and the Washington Department of Fish and Wildlife helped in editing and reviewing the report. And the Coates Foundation was one of the foundations that provided initial support for looking at the oil spill potential of the region. And with that, I would like to have my last slide, which is basically the very significant aspect of this project, which was the gut contents analysis that Matt will take over and discuss at this time. And thank you for listening. I will be happy to answer questions at the end of this talk.
Great.
Matt, do you want the screen now?
Yeah, sure. Thanks, Gary. I will try and present here. Is that coming up?
Looks good.
Okay, great. Yeah, so just taking a step back, Gary described a lot of various aspects of this. I think everyone's very familiar why salmon are important. Probably most people watching eat them. They're also a really important prey resource for higher trophic level predators. There's both local recreational and commercial fishing, and then there's a strong cultural impact and value to salmon and in indigenous communities and communities just more broadly. And so the purpose of the diet component of it was to look at the extent to which salmon might be focusing on various prey species, predominantly sand lance and Pacific herring. And for those that are not familiar with sand lance or sand eels are prevalent throughout the whole northern hemispheric system. So this is a picture I took in Iceland while I was walking on a beach trying to describe to a British friend who's out there with me some of the stuff that we're doing, and this wash stripe up. So they're really all over the place, and they're important in all the ecosystems in which they are found. The way that we were sampling these is using Van Veen or sediment grabs. So putting those down, sampling the sediment, and then pulling up sand lance within those grabs, within those sediments, and then looking at the correlation between the sediments that we find sand lance in and those that we don't, and trying to characterize what potential habitat is that way. And so we've been doing this in collaboration with Gary through various field studies, and then more broadly on a pretty intensive approach for the last, this will be the 14th year coming up, through a class that's run each fall on pelagic ecosystem ecology. And we go out and we sample the system and have a fish component using acoustics and some grab sampling and some other aspects. And so this map on the left is showing you some of those samples or areas that we found sand lance. Gary mentioned the San Juan Channel Sandwave Field. This is really the first place sand lance were found. It's where we did our submersible operations, and it's a very consistent site. It's something that we use as an annual reference point and sample this weekly throughout the fall season each year for the past 13 years. And then again, there's some of these other areas. So these areas that are in high tidal currents, areas like this top wave field that's on North Peapod Islands, just to the right of Orcas Island, and then these glacial banks such as Hind Bank and Salmon Bank, Middle Bank, East Bank, and some of those other areas. So in terms of sampling salmon, there's different ways to do it. One way is to throw nets in the water and sample, and there have been efforts to do this. I was part of a 2020 this year's effort to go out as part of the International Year of the Salmon to sample some of these fish on the high seas. Just to give you a sense for what that looks like, we were using really long nets, as shown here. We used 4 different boats, and we went out really way off the shore and looked from the Gulf of Alaska all the way out to the Aleutian Islands. So just to show you where we found king or Chinook salmon, and then coho salmon. This type of effort was a multi-national effort, huge amounts of money. We're still catching relatively few salmon. And so it's an effective way to look at where fish are out in the open ocean. But in terms of what we were trying to do, we built off of cooperative research with both community members that were out recreational fishing, and then charter operators that were doing this as a commercial enterprise. And it was a really effective way. I started working with one operator about 5 years ago, and then under this project, we expanded to approach quite a few more. We approached 30 operators, and about 14 of those were open to this. And we had a relatively good participation in these charter operators holding on to the guts of salmon from the clients that were catching fish. And so they provided those, held on to those for the year. And then in the fall, I would put students on analyzing these. And so we would weigh the stomach contents, both empty and full, and then we would count the number of individual prey items in there, and then also weigh all of the prey type, all the prey items by type. And so we used a few different methods to try and characterize diet. One is frequency of occurrence. So this is essentially, is a prey type available or present within a stomach, and then look at that as a fraction of the total stomachs where it's not present. There's the numerical method where you are simply counting up the number of prey. But when you're looking at something like crustaceans versus a herring, there's obviously size differences there. And so what I'll be showing is the gravimetric method, or the mass method of abundance, where we weighed all the different prey by type and then looked at the relative percentage of the diet. And then something else we looked at, which goes back to something that Gary mentioned, was exclusivity. So we're trying to figure out the extent to which a salmon had only one type of prey in their stomach versus multiple types. And the idea there is that would give us some idea whether or not they were actually specifically targeting something like sand lance in the sediments, or potentially hitting a specific school of fish, either herring or sand lance or various crustaceans. And so we were interested in all kinds of salmon. We had pink salmon as well as Chinook and coho salmon. I'll just be talking about the Chinook and coho, as that's what the project was focused on for the most part. And so in 2021, herring was the vast majority of stomach contents for these fish, with crustaceans, which is a variety of different shrimp species, and euphausids were about 13%, and sand lance just 1%. And there was not a whole lot of exclusivity for those fish that did have sand lance. Multiple fish had sand lance, but not large numbers of them, or not large component of the diet. In 2022, that really changed. So we had about half of the mass within salmon stomachs overall was herring, but about a quarter was sand lance. So things were changing year to year. And so I think, getting back to Gary's point, this is something where we really want to expand on this over multiple years and kind of look at how that plays out across a larger time frame. Just looking at king salmon or Chinook salmon, again, it was highly dominated by herring in 2021, and then a decent bit of crustaceans and very low sand lance. But that changed where sand lance became the dominant, or at least the plurality of the diet, about 40%, so more than herring or crustaceans in that year. There was, again, pretty low exclusivity with sand lance, which suggests that they're not maybe just targeting those on their own. With silver salmon in 2021, again, herring was the major diet component at that point, with crustaceans coming in second. And then in 2022, there was more sand lance that year, but again, silvers had a large portion of herring. To some extent, this was due to small sample sizes. A lot of the silver or the coho salmon were actually empty. But we did find that 50% of the stomachs overall did have sand lance, even though overall it was a small proportion of the diet. So when there was prey present, about half of those fish had some sand lance in there. So just some challenges that we had. We started up this particular part of the project right at the beginning of COVID. So it was very hard working with charter operators, including those that I had been working with for a few years before. Health restrictions meant that clients were going out. The closure of hotels in the islands meant that even if the charter operators were going out and they had clients interested, the clients couldn't find a place to stay. We unfortunately had a large number of salmon stomachs taken in 2 years early in the season by WDFW. Despite the fact that they were funding some of this, they were interested in the data too, and so they were taking salmon from charter operators that were out there, including the ones that we were working with. And then this past year, there was a lot of fishing happening, but there were periods of prohibited retention. So there was catch and release. So that meant they were catching fish, but not keeping them. So we didn't have the stomachs to take a look at. So just getting back to where Gary was talking again about, this is again the San Juan Channel sand wave field where we catch a lot of fish. And then down on the bottom right is where we had one Chinook salmon with sand lance in there. some of the charter operators that we've worked with in the past have said that they are regularly fishing off of this area and catching fish full of sand land. So, but have moved away from this area because it's become kind of overrun with fishing activity and other boat traffic. So that's something that hopefully we could expand on a little bit. Again, Gary had shown that Salmon Bank is very consistent in terms of having sand lands really throughout the bank. And along the shoreline, and South Beach there is also a place where we beach sand and regularly find sand lands, and Chinook salmon here. We're shown to have sand lands in their stomachs there as well. But again, we want to bump out the sample size on that. And then Hind Bank, further offshore, we found sand lands throughout portions of this feature, this glacial bank. And this is again someplace where fishermen are often targeting Chinook salmon and have noted that sand lands are often in their diets, kind of beyond the 2 fish that we have to show here. So this is again something, as Gary mentioned, that we're trying to expand some of the sampling in the glacial banks as well as the banner banks that he was talking about, and try and get larger sample sizes so we can see whether or not there's more than anecdotal evidence, but some statistical power in tying these salmon to particular sand lands habitats. And so with that, I wanted to thank particularly our partner charter operators that were going out there and catching fish and really doing this as an in-kind contribution to the Friday Harbor Labs that support the class that we've been running for the last 14 years. To the students that were sampling all of these stomachs and pulling those out, and all the Friday Harbor staff, as well as all the funders. And I've just listed down here some of the other types of work that we've done related to this. One of them is a publication that just came out looking at the importance of and the value and opportunities for collaborating with fishing industry and in supporting marine science. I think that's something worth taking a look at. And then we've been doing, on the fish side of things, we've been doing quite a lot of other studies looking at distributions and habitat, looking at reproductive maturation, age and growth, diet, and overall ecology. So we're trying to build this out in different ways. And I think with that, I'll turn it over to John to keep on taking us forward.
So hello, is my screen visible there with the story map?
It looks good.
Okay, great. I gotta get rid of the, oops. There we go. Okay, so there are a number of deliverables from this project. There's going to be a technical report available, which will have the real details and the really heavy lifting. That will be available. Along with some maps that go along with that, along with actually a GIS project with a geodatabase and a sample map for GIS professionals that want to look at this. But what I'm going to run through just quickly, just to give a demo of it, is one of the other deliverables in this is a story map that that I developed with the team. And its intent is to be high level educational for the general public, and what we tried to do with it is put together in an engaging way some highly interactive maps. So I'll just quickly run through that. The presentation that you saw here has covered a lot of that material, but let me just quickly run through this. We talk a little bit. Oh, one of the things I'd like to mention is that there is also a hang on. This particular story map is part of a suite of story maps, a collection of story maps that we developed for a number of projects. There's a little bit of an introduction to the Salish Sea, a little bit about seafloor mapping, some educational material on the geology, and then the development of habitat maps. A project that was done just prior to this one and really concurrently with it is a project that evaluated the effects of oil spills, in particular sinking oils, and how that might affect habitats, which we tried to address also in this project. And so this is a collection of story maps, and I reference these throughout this particular story map that documents this project. So we talk a little bit about some of the research that has gone on in San Juan Channel. This is a picture of the San Juan Channel sand wave field. Talk a little bit about that Matt and Gary talked about in terms of where sand lands have been found in that sand wave field. There was also, that was mentioned, showing some of the video that was all part of a dive operation that Gary and Matt participated in, that actually showed recording of what the sand lance were doing in the sand wave field. The video is available that shows how the sand lance are coming out of the sand wave field. That's in this story map, so you have access to that. And then talk a little bit about the mapping, the various mapping efforts to look at a potential habitat. This is the area around Obstruction Pass that Gary mentioned. And we talk a little bit about where sand lance have been found. What I'd like to do here, I'm having a little trouble with, I've got to get rid of the window here that shows everybody. There we go. Okay. So all of these maps, almost all of these maps are interactive. So it gives you the ability to pan and zoom, examine any of these particular areas that may be of interest. Here I'm showing Salmon Bank. These are the yellow dots are where Pacific sand lance were found. And many of these features, you can click on these features and it'll identify the particular feature. For example, these outlined in brown are the dynamic bed forms. I'll go and shrink that. And these are all the various areas where sand lance had been found that Gary and Matt have provided the information in terms of sand lance presence. And then we mapped on top of that where we have found salmon. And so with these maps, you can go in and identify particular. Here we're talking over here in off Decatur, the sand lance in the salmon. The yellow features, the yellow with fish icons, are those that have salmon that have had Pacific sand lance found in the guts. And here we're mapping the various habitats, the dynamic bend forms, the banner banks, where salmon have PSL in the guts and where PSL have been found in the Van Veen samples. And then I'll run through this quickly. The story map also zooms in on particular areas where we're featuring what we found. So there's a salmon bank, obstruction pass that Gary had mentioned previously. This is kind of a summary of the sand lance in the salmon using the gravimetric method for the years 21 and 2022. Another piece of this work that Gary touched on was this assessment of these various bed forms and banner banks in terms of the potential, at least a perceived potential for presence of Pacific sand lance in the sediments. And so what we have done is gone through and identified all of these and highlighted. So here we've got a dynamic bed form that's been rated as fair. This particular bed form in San Juan Channel is rated as the highest. And so in this map that we provided a map of the assessed potential habitat. And then the next one just features those that we rated good or better. There's a couple of sliders in here where we just show the, whoops, there we go. We show the bathymetry on the, or the hillshade images on the left, and on the right-hand side, we show the interpretations of where we have salmon and the habitat assessments. Gary also mentioned this intersection with the oil spills work, and here what we tried to do in the slider is on the left hand of the slider was the assessment of how oil spill might behave on the seafloor. And the blue area is where perceived that it would be assessed where sinking oil might be swept through by currents, or for example, the green areas where it might accumulate. And then on the right-hand side of the slider is the Pacific sand lance habitat assessment. Okay, so one other thing I'd like to just show quickly. Uh-oh, I think it, are you able to see this screen? It says my screen sharing is paused.
We're still seeing it.
Okay, are you seeing a PowerPoint slide?
We're seeing further details. I think we're still on the story map.
Okay, this is where, hang on a second here. I'm gonna this is where on a Mac, if you've got multiple desktops with Zoom, okay, hang on. Oh, I'll just talk about, okay, so there's, oops. So as I mentioned, there's several deliverables, the technical report, the story map. There are some maps that go along with the report that are large scale maps that are georeferenced PDFs. In addition to that, we've put together a GIS project that has a geodatabase and a sample map that goes with that, with some metadata that goes with it, so that much of this data that you've seen in the story map or the other maps will allow somebody to go do some additional analysis. So, and we're going to make that information available by the end of the month, and we're working with our partners here, Department of Natural Resources and Fish and Wildlife, to provide a link to all that information. So that's basically what I have.
Great, thank you. Let's see, I'm going to go ahead and take your screen away from you so that we can, let's see, there we go. See everyone. And I noticed that we are actually having a bit of a conversation already in the chat. Some of those questions are already being addressed. So that's fantastic. That will save us some time. I guess I want to ask the project team, of the questions that you've noticed in the chat, is there anything that you want to expand upon? I know that they're pretty brief answers right now. Anything else you want to touch on?
So I'll chip in here, but I think it should be followed up with from Matt as well. Just following up on the chat. The one thing we do recognize is that salmon feed, they're optimistic feeders, and they feed on different things. In fact, we found in Alaska they're even feeding on worms in the sea, in the substrate. So we know they feed on different things. We're trying to focus on sand lance specifically, even though they, this is only a part of their diet. And we're looking at where they may be targeting these foraging areas. So we don't have it right down pat at this point, but this is what we're trying to look for, is evidence to indicate that the salmon know where these sand lance are occupying the substrate. And so Matt, you might kick in here as well, because I know you have some thoughts on this.
Sure. Yeah, I think there was a good comment. How do you know that a salmon that happens to be somewhere close to a particular bed form is foraging in that bed form? And we definitely don't have direct evidence of that. I think what hopefully we're looking at this. We've been doing this before this particular funding for the project, and plan to do it long after. And so hoping to build up enough of a data set where we can start getting some statistical, some ability statistically to make some inference that way. And like Gary said, trying to get pictures of fish that have striations to see whether or not they go in there and actually flush fish out. And one of the charter operators that I worked with, I asked him if he took pictures. We had asked him to take pictures, and then he's kind of forgotten. And I said, well, do you have any pictures of clients, showing the fish like this? And he's like, yeah, but we always turn the pretty side out. So yeah, they are marked sometimes, but we'll put the less marked side out. So I think anecdotally, it seems like there may be some of that happening, but it's a little bit hard to say anything conclusively. And there were some comments too, I think, on juvenile salmon or smolts as they're going out. No one's catching them that we are working with. So I think the state, and there are other sampling efforts that do capture smolts. And I think the people who are involved in that would have a lot more insight than us. We do see some potential competitive effects with pink salmon emergence early on. So that's more, rather than a predatory interaction, probably a competitive interaction between early emerging pink salmon. There's a big pulse, a difference in even an odd year abundance coming out of the Fraser River salmon. And we see that signal, that every other year signal in sand lance. So that's kind of an interesting ecological trend that we're tracking over time and trying to get a better sense of too.
Great, thank you. For someone who's entered a question, I mean, we've got a pretty good response here in the chat. Anything you want clarity on that you didn't hear in the chat? Anything and you feel free to just unmic and speak up. Okay.
Just to note, a lot of people had said, where you're catching fish and different ideas of where to look. This is really useful. So we'll try and save the chat here and use this as a way to inform future sampling.
Great.
Yeah, this feedback is good. If people know where they've been catching salmon and they see sand lance in their guts, or know they've been feeding on sand lance, any information they can share with us would be very helpful, because then we can start targeting those areas for going out and sampling and looking at with video and what have you. So that's very useful to us.
So we are just shy of 5 minutes. Before I wrap up, anything else, Gary, Matt, or John, that you want to speak to before I kind of share contact information and wrap us up?
So one thing I would say is that COVID really put a damper on our ability to able to really recover the amount of data that we needed in the form of salmon stomachs. And the reason for that was that, as many people can understand, is that the secure yourself in place regulations, then people weren't going out fishing. The charter boat operators really had a hard time. I think Matt can speak specifically about that. Their business just fell through the floor, and it's been slow coming back. So we really would like to have had a lot more stomachs to look at than we have now. And so we really don't have a statistically robust analysis here. And so we're trying to pull these straws together to make sense of what we have. And this is what, we've presented our conclusion here of what we see happening. And it certainly has been very, very useful. And it looks like it's going to be able to direct us or whoever follows up from this in getting a really good feeling for how salmon, especially Chinook salmon, are using the substrate for targeting their prey, and that's basically what we're after. Matt, you can add to that, I'm sure.
Yeah, I just put a pitch into the chat. I think a lot of people here may go out and recreational fish, and some of these salmon came from some friends who go out and just do that with their family. And if you are out fishing, getting to Gary's point of improving our sample base, and you're willing to hold on to some of these stomachs, or we can work with you to figure out a way to take them off your hands. We're always happy to expand the sample size. So yeah, thanks.
Great. Okay, well, I'm going to just wrap us up. Thank you very much, project team. This has been a great webinar. For those of you who are interested either in learning more about this program, want help being directed to the webinar recording in a week or two, or who just want to have a little bit more information around our Habitat Strategic Initiative team, please do feel free to reach out to us. And thanks everyone again for participating in the webinar today. As participants, those have been great questions. I will save that chat and forward it on to the project team so that they have documentation of that. Okay, I think at that point, I think we can wrap unless you have anything else you want to add in 2 minutes, Gary.
Yeah, I was going to answer. There was a thing on the chat about the focus on sandlats population dynamics or their impact on salmon and the bird populations. Now, the bird population definitely is important. And although we're focusing right now on salmon, and this is a salmon recovery thing, we have in the past, and we will continue to look for how birds forage on these as well. This is a tremendously important. And I got involved in sandlats in my work in Alaska on rockfish, because a lot of the puffins and a lot of the mirrors, common mirrors, were hitting the wheelhouse that was lit up at night and dropping all the sandlats that they had collected. So we know that birds, a lot of birds, forage on sandlats. And we found out that these birds were foraging right over an area where sandlats was in the substrate. Okay, that's all I have.
Okay, excellent. All right, it is the end of our hour. So again, thank you everyone. And please reach out if you have any follow-up questions.
Thanks, Elizabeth.
Thank you.